everyone, this is Jess Minniclock and I am recording my Module 3 practice, Re-engineering the Bristlebot. So I first started by creating the Bristlebot with the materials and instructions provided to us. You can see here this is an example of what my Bristlebot ended up turning out as. It is spinning a lot and not very controlled. When I was building the Bristlebot, I thought about the battery, and we were provided a 1.5V battery, and I took a 3V battery that I had downstairs, replaced it onto the Bristlebot, and tried that out as well. This one did, I feel like, move in a more streamlined direction and appeared to be a little bit more controlled. When it came to the ask in the engineering design process, we were asked 4 questions. When highlighting about how the Bristlebot works, I circled the motor and the battery because that is what is giving the Bristlebot power. Also looking at the bristles on the toothbrush head, that is very helpful when providing movement for the Bristlebot. So those are 3 key components to the Bristlebot's function. When modifying the Bristlebot and thinking about materials to redesign it, I wanted to think about how the Bristlebot could be moved without a battery power, and if this would allow me to control the direction of the Bristlebot, because it was fairly uncontrolled in the first couple of videos. So imagining how to do this, the Bristlebot can move without a battery or motor by manually creating vibrations to give energy, maybe wind or air pushing the Bristlebot in a certain direction, or changing the angle of the bristles. Then I started to create a plan to try this. So I decided to create manual vibrations to give energy to the Bristlebot, hoping that it would move. So I have a cardboard box here that I covered the top of, and I'm using a pencil tapping it on the top to move the Bristlebot. So when it came to creating this redesign, I first used the cardboard box and taped the top of it shut and tapped the pencil on the top. So as you can see, the Bristlebot is moving, but it is fairly hard to control and ends up falling off the side of the box. So I wanted to do better than that. So I took that top layer of cardboard off and I replaced it with a layer of paper and then tapped the pencil on there, and it was easier to move, but still difficult to direct its path. So when it came to improving the Bristlebot, I angled the bristles. This is one of the ideas I came up with in my Imagine stage of the engineering design process, and this allowed the Bristlebot to move forward a lot easier and it was more controlled. In the future, it would also be interesting to use a bigger box with a bigger surface area. That way you could experiment with softer and harder vibrations to see how that would change the Bristlebot moving, and also it would be nice to make the Bristlebot more visually appealing. As far as the figure 5.2 STEM practices, you can see the key here of how I highlighted the chart. The re-engineered activity highlighted a lot more of the STEM practices. Both of the activities we developed a model and used the model and incorporated technology with the battery and the motor, and you had to precisely follow directions in order to execute the design. But the re-engineered activity allowed more questions to be asked, defining the problems, carrying and planning out your own investigations, which allow you to explain why you made certain decisions and engage in an argument with your own evidence, and then communicate that information with your peers. So the 5.1 STEM lesson checklist shows the original activity in orange and the re-engineered activity in green. Overall, the re-engineered activity scored a lot higher as students were presented with a problem. They were asking questions. Students were able to take their own approach and have more creativity in solving the problem. Students are incorporating more of a science-based exploration by targeting a certain point of why the Bristlebot works. I chose somewhat because not a lot of math was incorporated, but students are using the engineering design process and hands-on using that activity to learn about the concept at hand, and students are given more of an opportunity to collaborate and share this solution because they're making choices. They'll have something to share with their peers. However, the original activity just gives students a script and there's not a lot of higher level thinking questions, which is why I overall or scored the original activity as no for most of the qualifications. And here is a reference that I used as I created my presentation. I'm looking forward to seeing what everyone else came up with. Have a good night.